ziua, suntem la Mobile World Congress 2017.
Vă prezentăm pe telecomtv.ro cele mai noi lansări ale industriei.
We are doing to expand the platform to the automotive industry, automotive vertical, and in particular the work we are doing in what we call the LTE-based V2X. In release 14, we have just released an initial version of the standard which will allow V2X framework, so which is the framework which we will use to allow cars to communicate with each other, so the so-called V2V, cars to communicate with the network, V2N, cars to communicate with pedestrian, V2P, and cars to communicate with the road infrastructure in general, V2I. So we started an initial release on basic safety needs. In release 14, we're going to expand that framework, and we're also going to migrate to 5G V2X, which will be the fully fledged and the fully capable platform to address the long-term needs of this industry. One last interesting feature for LTE is the low latency LTE, and that starts to get interesting because we really modify the physical layer of the LTE to allow for lower latency over the air, which is a way to expand the possible services that the LTE platform can cater for, and also expand to the delay critical services, which is another area which is deemed very promising and coming up soon. Of course, these were just a zoom in on a few selected areas which show you how we are expanding the ecosystem, but of course there is a lot more going on in terms of LTE evolution. Which brings me to the next part of the presentation, is what we are planning for the 5G. So first of all, going back to what was just presented, in terms of 3GPP, of course, has decided that we will do a technology submission to IMT 2020, and we already decided that our technology proposal will include both a new radio, 5G, which we call ANR, and I assume everybody is familiar with this term by now, and also the LTE. Again, the package will include both things, and maybe some of the verticals, some of the use cases will be initially served by the LTE platform, some will be used by the new radio platform, and in the long term, of course, we'll migrate all the services and use cases to the new radio platform, but at the beginning, we expect to serve with both platforms the different use cases as the market demands. So, in terms of timeline and phasing, this I assume everybody knows already. So we decided to phase the work for the initial release of the specification in 2 phases. First, we will have a first release which will be released in release 15 by September 18, which will serve some early market needs, and then we will have a second release by March 2020, which will serve will contain the full submission for IMT 2020. One key requirement we established all along in the design phase is that we want to design an ANR platform, the new radio for 5G, so that is forward compatible at its core, so that later on we can add to the platform other use cases and services in a seamless, in an optimal way. This is really a change in that design philosophy which we have adopted in 3GPP. Of course, 3GPP to a certain extent has always designed forward compatible system, in the sense we started with an initial release and we added feature on top, but we sort of added it in a suboptimal way, so we were almost hacking a little bit the system every time. This time we are spending a lot of time to design the system at its core, at the physical layer, so that we have placeholders, let me put it this way, so that we can later on optimally next use cases and next features. So we have come out with a work plan for the first release of the specification, release 15, which has these intermediate milestones. Next plenary next week has one of these interesting milestones, which we need to decide is the bubble tree in the picture. So we are at bubble tree. When we finish the bubble, we have done, we succeed, we have declared victory and move on. But we are in bubble 3, so we have a detailed work plan to get us to completion of the first version of the specification, which has the following initial targets. So we will have two deployment scenarios. One is what we call non-standalone, and one we call standalone. The difference between the two is that in a non-standalone mode, you anchor the connection on the LTE, on an LTE carrier. We are evaluating different architecture options. And in terms of use cases, we're going to focus on enhanced mobile broadband and some low latency, high reliability capabilities to be determined the exact capability set in this case. We are looking at forward compatibility and frequency ranges below 6 GHz and above 6 GHz. In terms of actual studies in run, so we have completed the study on scenarios and requirements. For next generation access technology, there is a technical report you can read if you're interested. We have developed a new channel model for frequency spectrum above 6 GHz, which was needed for designing the new access technology to access these high frequencies. And we have started this new radio access technology, the study will conclude next week, upon which we will build the normative phase of the work with the first work area. Also, the system aspects have been covered by the Smarter project in NSA1, which completed with the 4 technical reports you can see of the different use cases identified as high priority. And also there is an ongoing project in the SA2, SA3 on the system architecture and security aspects, which are also quite important, of course, because in 3GPP, not only we design the access part, but also we really design end-to-end solutions, and that's very important. That's what does allow us to thrive as an industry. And that concludes my short update on the 3GPP status of the standardization. Thank you.